Hello, Dr. Munira. We all saw in the last video how to build up the system. So now I'll show you how to set up the simulation. So before showing how to set up the simulations, I want to show you a few more things. So how from where I got this structure file, from the crystal structure file. So if you open the web browser, you go to this website. You can search American Mineralogist Crystal Database. Then the first link should be the this website. So you open this website here. In this, you go here, chemistry search, yttrium, barium, copper, and oxygen. So these are the atoms. So search selected elements. So here yttrium, barium, copper, and oxygen. So that's your elements in your crystal. So when you hit search, it gives you all the reported crystal structures. Here you can see already. So this oxygen is 6.82, copper is 2.94. So this is already doped system. So here you have a different concentration of oxygen. Similarly, you can see there are different oxygens. So I selected this one, which is a pure yttrium, barium, copper oxygen system. So this is the system which I showed you. If you want to build the systems with a less mole fraction of oxygen and the copper, you can download those systems from here also. And if you want to add, if you are thinking of adding more doping with the other elements, so here are the systems. So here is the strontium and tellurium. So here with only the barium, copper, and oxygen in different concentrations with the palladium. So you can go through. You can find the systems whatever you want to build here. Just you have to download the zip data. The zip data file can be directly read in the master interface. So you can import that into a master interface. How do you import? So file, go to file, import structures. Then in here you can import. So I'm importing the same file, but you can import any file here. See, this is the second time we imported the structure. Here you can go to style. You can change the style. So here you can click elements. So here is the system. So here's the system. So that we download. So like that, you can download any system. You can import any system. So now we have built the supercell, 2 by 2 by 2 supercell. So in this supercell, how to set up quantum-espresso calculations. So in order to set the quantum-espresso calculations, we need pseudo potentials. So what are the pseudo potentials? So pseudo potentials are the ones which represent your system electrons. So here you go. So here you go. You go to yttrium. Okay, so yttrium is one of our element. You select blip. Okay, so right click, save linkers. You can save link in your directory, documents, documents, Schrodinger, yttrium, barium. So here is a yttrium. Okay, and similarly you can download barium pseudo potential. Yeah, this is the one we save. So try to keep the same type of pseudo potential for all the systems. Yttrium, barium, copper, now here is the copper, and then oxygen. So here we go, oxygen, save linkers, oxygen. So now we have the pseudo potential of all the 4 atoms saved. So let's go back to the interface. Here we select the system, go to click tasks on the right top corner, materials, then Quantum-espresso. So in the Quantum-espresso, you have to say perform calculations. So that's automatically selects the system in the project table. And here you can keep a simple frozen state to check up your calculations. And in the pseudo potential, you have to browse documents, Schrodinger, yttrium. So here it automatically selects the pseudo potentials. So yeah, so that's the cutoff distance that we can set up here. So here you can go. So spin non-polarized, blip is okay. Dispersion correction, if you need, you can include the dispersion correction. Automatic K-point mesh, this defaultly takes 10 by 10 by 10. You can check in the literature. If you feel you need more K-point mesh, then you can increase the K-point mesh. and then here you don't need to change anything. So just we need the optimization, we need the density of states and the band structure. So it also the internal convergent tests. So that is okay. So don't need to change anything. Just hit save and then hit run. So once you hit the run, this starts the calculation. So the calculation is running here. You can monitor it. It started the calculations. Here is the log file. So here it will print all the data. For your system of 104 atoms, it would take really lot of time because you are using a i3 processor machine. So the machine is too small. So because of that, your time consumed for the calculation will be much higher. So once you have the i7 processor machine is exclusively dedicated for the simulations, you can really run longer simulations. For bigger systems, you can compare the systems. You can get their electronic properties, electric properties, as well as the magnetic properties. I'll show you how to do those things. So this is the first step to learn how to set up a simulation and how to start the calculations. So once this calculation is done, we'll see how to analyze these results and how to make sense of these results. Okay, so you try this exercise and we will discuss further. Thank you.